solution. And the same process can be applied with the b's with the other base numbers, so 3 and 5. Now, this group of permutations has 4 interesting properties that we're going to look at. The closure property, the associative property, the identity element, and the inverse property. The closure property states that when any permutation is combined or followed by another, the result will be a permutation of the set. So we can take any 2 permutations, for example, this with the second line is B, A, C, D, E, and follow it with this permutation. What we're going to do is combine the 2 permutations. We're going to start going left to right. We see that A goes to B, so now we go to this permutation and see that B goes to B. So in the result, this A will go to B. Again, B goes to A, so in this permutation, we go to A, which goes to A, so therefore B goes to A. C always remains the same. C goes to C here, C goes to C there, so C is going to go to C. In this, D goes to D, this D goes to E, so D goes to E. And finally, E goes to E, this E goes to D, so this D will end up at D. And the result is one of the permutations found in the group that was listed before. Now we can do the associative property. This is basically saying that if you have 3 permutations, one followed by another, it doesn't really matter what order you combine them, you're going to get the same result. So here on the left, we combine the first 2 permutations. A goes to E, this E goes to D, so A goes to D. B goes to D, D goes to E, so B goes to E. C remains the same. D goes to A goes to B, so D goes to D. And finally, E goes to D, C goes to A, so E goes to A. So we have the result of these 2, and we want to combine it with the third, and we get this result, which again is part of the group that I showed before. So now we want to see if we're going to get the same answer if we combine the last 2 first and combine the result with the first. So we combine these 2 over here, came up with this result. We then combine that result with this first permutation, and sure enough, we get the same answer. Next, we want to see if the group has an identity element. For real numbers, the identity element states that if A times B equals B times A, which equals A, then B must equal 1. So for the permutation, we want to see if we take one permutation and we multiply it by this initial solution, then we will get the first permutation back as a result. And similarly, if we switch them, so we have the first permutation up here being combined with the second permutation, we'll get the same result. Therefore, this A goes to A, B goes to B, C goes to C, D goes to E, and E goes to E is the identity element. Next is the inverse property. We want to see what element we can combine, or what permutation we can combine with another permutation, basically to get the identity element. So if we take A goes to A, B goes to B, C goes to C, D goes to E, and E goes to D, what can we combine it with to get the identity element? And it turns out that if you combine it with itself, you get the identity element. A goes to A goes to A there, so A goes to A, B goes to B, C goes to B, and B goes to B, and so on. So there are other magic letter puzzles that we can construct with different groups of permutations. For example, we can construct a magic letter A, shown here, and with this puzzle, we want the sum of each diagonal, so these 3 and these 3, to equal with the center line. We want those 3 to all be equal. This magic letter gives a solution with the diagonal sum of 10 and a solution with the diagonal sum of 9. So as you can see here, 5 plus 3 plus 2 is 10, 3 plus 6 plus 1 is 10, and 5 plus 1 plus 4 is 10. And over here, all of those will equal 9. So the permutations that can be done with this magic letter We have the initial solution, so we have the identity element, and the only permutation that we can do with this to keep everything the same is switch D and F with B and E. So A and C will remain the same, but B goes to D, D goes to C, E goes to F, and F goes to E. This is because D and B have to stay in the center line. If they're moved anywhere else, then the center line sum will not be equal to the diagonal. So in conclusion, what we basically showed here is that every magic letter puzzle is associated with a group of permutations. The permutations in the group show how to manipulate your initial solution in order to get other solutions. And this is a really basic example of groups, but grouping is really important in higher mathematics. This is just an easier way of kind of looking at it and starting to understand it.
Are there any other magical letters?
Yeah, there are a lot. You can, almost all of the letters, it's just the way you construct them. And, you know, we looked at the magic letter C, T, you can do anything. A lot of the ones that we looked at had the same group of permutations as the V. The A was one that was different. You could only move it around once, but a lot of the others had the same thing.
Would A or a capital I or capital H would have 3 rows of 3? Would you count those the same way as the A?
Yeah, like when we did the letter C, we drew it out as this, and we added the sum of these 3 to equal the sum of these 3 and the sum of these 3. So like that. Yeah.
That one I believe it or not is the same group of 8.
Yeah.
It's not obvious that it's that way, but it is. Okay, the next talk will be in about 10 minutes.